Question number 46. The topic is on EM wave propagation. Here, two medias are considered, two dielectric medias are considered with a reference plane is equal to Z is equal to 0. Above it is Z is medium 1 and below it is medium 2. Medium 1 has Z less than 0 and medium 2 has Z greater than 0. So the properties of the mediums are given as epsilon R1 is equal to 2, which is permittivity. The permeability is epsilon R1 is equal to 1. Both are relative permittivities, and conductivity sigma 1 is equal to 0. And for Z greater than 0, relative permittivity epsilon R2 is given as 4 and permeability is given as 1 and conductivity in the second medium is given as 0. And another important thing that is given as this is not a charge free surface. This is a surface which has a surface charge density of rho s is equal to zero point 0.2 coulombs per meter square. So we have two boundary conditions for these sort of problems. For example, let us consider our electric field intensity E1 is equal to 3ax bar plus 4ay bar and 0.56 EAZ. So if we consider the propagation in the medium 2 as E2, we have to find this one. So we have two important boundary conditions that are tangential components of electric field intensity are equal. So what are the tangential components for E1 for E1? These two, ax comma ay form the tangential components for z is equal to 0. Ax comma ay form the tangential components, and z component is a normal component. So considering that, so Et1 is equal to Et2, which is we have tangential component in the second is equal to Et1 is equal to 3ax bar plus 4ay bar. So we have to find E2 is as Et2 plus En2, where N2 is a normal component. So Et2 is already there, so En2 has to be found. So we have the boundary condition for the normal components for the electric fields are, if we consider the surface where the electric flux density in the medium 1 is dN1 and the electric flux density coming out of this is dN2 with surface charge density of the reference plane that is considered as rho s, then we have dN1 plus rho s is equal to dN2. Which is so dN1 can be written as epsilon naught epsilon r1 into En1 plus rho s is given as 0.2 nanocoulomb per meter square is equal to epsilon naught epsilon r2 into En2. En1 is given here as 0.56 EZ. E0 is not there. E0 is equal to 1 by 36 pi into 10 power minus 9. So we'll have E0 into epsilon R2 En2 minus epsilon R1 En1 is equal to zero point 0.2 into 10 power minus 9 coulomb per meter square. So if we solve this, we will have 4 En2 minus 2 En1 is equal to zero point 0.2 into 10 power minus 9 by epsilon naught, which can be given as 22.6 if you solve this. And now, in order to calculate En2, 4En2 is equal to 2 into En1, which is 0.56 plus 22.6. So you will have En2 is equal to 23.72 divided by 4, which can be given as 5.93. The unit of electric field intensity is volts per meter. So finally, you have a tangential component and you have a vertical component. So E2 is finally given as ET1, which is ET2, which is given as 3ax plus 4ay, and now the tangential, the normal component is 5.93 into az. So the option that is given is option A.